answer key and the step-by-step walkthrough of each of the problems on the review sheet. Again, this is for topic 2, part 2 review. Please remember this test is tomorrow, which is March 11th. So Thursday, March 11th is the test. Your Math Excel 2.4, Math Excel 2.5, and then also your packet or your Jamboard slides, for those of you who are remote, those are all due tomorrow. They were assigned over a week ago. The Math Excels were assigned on Wednesday, March 3rd. Your packet or Jamboard was assigned on March 11th. Thursday, March 4th. You've had 7 days to complete, and the packet, 8 days to complete the Math Excels. So those are due tomorrow, no exceptions. The Math Excels are classwork grades, and then the packet is going to be taken for an assessment grade. So if you don't do those, there's going to be a huge hit to your grade. So tomorrow is your topic 2, part 2 test. It's over sections 2-4 and 2-5. The first one on the review sheet, the equation y equals 7 6/10 x represents a proportional relationship. So we know that that represents a proportional relationship because it's in the equation is in the form of y equals kx. Okay? Nothing is added to it, nothing subtracted from it. So any equation that's in the y equals kx is a proportional relationship. X is your independent variable, y is your dependent variable, and then your k is your constant of proportionality. So when it asks what is the constant of proportionality, you need to look for the coefficient of x. The coefficient of x is 7.6, so that means that the correct answer to this one is letter B. Okay, for the next one, the graph shows how many sheets of paper a paper folding machine can fold in a certain number of minutes. So when we look at our graph, we can see our time is our independent variable, that's along our x-axis, and the number of sheets being folded is our dependent variable, which is going to be the number of sheets folded, which is along your y-axis. So the first question asks, what is the constant of proportionality and what does it mean in this situation? So again, constant proportionality is that reoccurring ratio that we're seeing when we reduce all of our values down to the same fraction or the same value. So because we don't, on our graph, we don't have a 1. Okay? Whenever we have 1 as our x value, our y value is going to be our constant of proportionality. We don't have that here. Okay? We need to look for a point where we can find the constant of proportionality. So I look for points where it meets exactly at a cross. So exactly at a corner. So 23,000 meets at a corner. And then also 46,000 meets at a corner. So that means my ordered pair is 20, 3,000. And then another ordered pair here is 40, 6,000. So because I have an x and a y, I can calculate the constant of proportionality. K is equal to y over x. So when I do 3,000 over 20, my k value is 150. So my constant of proportionality, k equals 150. Okay? And what does that mean? That means that every minute, (150) sheets of paper is folded. So then another ordered pair that we can use, we could use 46,000. We could use 23,000. We can use any of those values. So if I use 46,000, that means that in 40 minutes, 6,000 sheets are folded. If I used 20, 3,000, that would mean that every 20 minutes, 3,000 sheets of paper are folded. The last one on this page says the tables show the number of green and purple beads Mia and Riley used to make 5 different decorative picture frames. Part A, are the numbers of green and purple beads in Mia's picture frame proportional? Write an equation if the relationship is proportional. So we first have to determine if it's proportional, and then we have to write the equation if the relationship is proportional. If not, explain why the relationship is not proportional. So when we look at Mia's picture frames, again, we're looking for our dependent over our independent. In this case, we're looking for purple beads over green beads. From this, we're looking to see if the relationship is proportional. So we need to look at each one of our values to see if they reduce down to the same amount. So 7 divided by 2, 14 divided by 4, 21 divided by 6, 28 divided by 8, and then 35 divided by 10. So when we look at each one of these ratios, they need to reduce down to the same value. 7 divided by 2 is 3.5. 14 divided by 4 is 3.5. 21 divided by 6 is also 3.5. 28 divided by 8 is 3.5. And 35 divided by 10 is also 3.5. Each one of my values reduces down to 3.5. So that means my relationship is proportional. So I can write yes. My constant of proportionality then is 3.5. So my equation is y equals 3.5x. Okay. So because I know it's proportional, I know I can write it in the graph, or in the equation of y equals kx, which is y equals 3.5x. So that was for Mia. Riley, we need to check for her proportionality as well. So again, we are looking for dependent over independent, which in our case is purple over green. So for Riley, it's 8 over 5, 13 over 10, 18 over 15, 23 over 20, and then 28 over 25. So each one of these needs to reduce down to the same value to make the relationship proportional. So 8 divided by 5 reduces down to 1.6 over 1. So when I do 8 divided by 5, I get 1.6 over 1, or 1 6/10 over 1. 13 divided by 10, I get 1 3/10 over 1. What do you see? We see 2 different values. So because we have 2 different values, our relationship is non-proportional. I don't even have to worry about the other 3 because I know that my relationship is non-proportional. So the second question asks, are the number of green beads and purple beads in Riley's picture frame proportional? And we can write no. The ratios are not equal. And that's a perfectly good explanation of if a relationship is proportional or not. The next one, at a carnival, Marcus buys 8 tickets for $12. If each ticket costs the same amount, write an equation that represents the total cost y of x tickets. Okay? So to be able to write an equation, and this should say money, not miles. Sorry, kiddos. Okay. So we need to write an equation. Okay. Our equation has to be in the form of y equals kx. If our equation's in the form of y equals kx, we need to calculate the constant of proportionality, which is y over x. So we're going to find the constant of proportionality first. Okay. So that is 12 over 8. Okay. $12 over 8 tickets. So I don't want to know about 8 tickets. I want to know about 1 ticket because I know that my constant of proportionality is always going to be the value of 1 or my unit rate. So 8 divided by 8 gets me to 1. 12 divided by 8 gives me $1.50. So that means my constant proportionality is $1.50. So if I know my constant proportionality is $1.50, I can plug that into my equation. So y equals 1 5/10 x. Okay. Again, x is the tickets, y is the total cost. So total cost is y, x is going to be our tickets. So if Marcus buys 25 tickets, how much money will he spend? So we know the equation that models the situation is y equals 1 5/10 x, where x is the number of tickets, y is the total cost. So y equals 1 5/10 times 25 will give us our value. So 1 5/10 times 25 is 37 5/10. So that means that Marcus will spend $37.50 on tickets. Okay, and then the last problem on our sheet says for every 6 pounds of oranges you buy at the farmer's market, the total cost increases by $7.98. Write an equation that relates the pounds of oranges bought, x, to the total cost, y. So again, just like we did in the last problem, we need to find our constant of proportionality. Okay, so our constant of proportionality is going to be our cost over pounds. So we know that it's $7.98 for 6 pounds. But again, we don't want the cost of 6 pounds, we want the cost of 1 pound. Okay? Because that gives us our constant of proportionality. So 6 divided by 6 gives us to 1. So $7.98 divided by 6 will give us $1.33. So it's $1.33 for 1 pound of oranges. So the equation will be y equals $1.33 times x. So $1.33 times pounds will give us y. So for letter A, we're looking for the equation y equals 133x. Now the second part says, use the equation you wrote to complete the table. So as we can see our table, we've got how much does 3 pounds of oranges cost and how much does 7 pounds of oranges cost. But then it also gives us a value and we have to figure out how many pounds we bought. Gives us a value and we have to figure out how many pounds we bought. So if I know I'm buying 3 pounds of oranges, I'm going to multiply the cost of 1 pound by 3 pounds. So $1.33 times 3 is 3 99/100, which is $3.99. Okay? So again, the pounds I just plugged into my equation, and I multiplied $1.33 times 3 to get the total cost of 3 pounds of oranges. Now this one's a little bit different because it gave me my y, so I have to find my x. So it gave me the y, and I have to find the x. So it goes back to equation solving. I've got $1.33 times x. The inverse of multiplying by $1.33 is dividing by $1.33. $1.33 divided by $1.33 is x. And 532 divided by 133 is 4. So that means that x is equal to 4. So if I bought $5.32 worth of oranges, that means I bought 4 pounds of oranges. 7 pounds of oranges, I'm going to do the same process over here. $1.33 times 7. And that gives us $9.31. And then this one here, we model it exactly over this one. They gave us our y value, we have to find our x value. So they gave us that the y value is $17.29. We know the cost per pound, but we don't know how many pounds we bought. So I have to divide both sides by $1.33, just like we did in the last problem here. Those cancel because that equals to 1. $17.29 divided by $1.33 is going to be 13. So that means that with $17.29, we bought 13 pounds of oranges.